Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example. A couple of equations to solve here, a couple of exponential equations. These are common ones that come up. We've done one similar to these. So starting with part A, we have 2 to the power of x plus 6 times 2 to the power of negative x is equal to 5. So that's the equation we're going to solve. Now, personally, what I like to do is take this 2 to the negative x, and I'm going to bring it down and make it positive, like this. And then what I like to do is I like to bring in a new variable, right? Because when it's 2 to the power of x floating around everywhere, it looks a little bit more complex. But if I bring in a new variable, let's say m, temporarily, I'll have m plus 6 over m is equal to 5. And now when I ask you to solve for m, it doesn't look as daunting, in my opinion, as if I asked you to solve for x when it's 2 to the power of x, like that, right? So just have to solve for m here, different ways to do it. Now, personally, I like to get rid of denominators if I can. So what I'm going to do, I'm going to multiply everything by the lowest common denominator. Lowest common denominator between 1, m, and 1 is m. So I'm going to multiply everything, this by m, I'm going to multiply this by m, going to multiply that by m, right? So I'll have m squared plus, here the m's cancel out, 6 is equal to 5m, bring the 5m over, m squared minus 5m plus 6 is equal to 0, like that. And then you just have a quadratic equation to solve here. You could put in the quadratic formula. I think this actually factors smoothly, right? Two numbers multiply to positive 6 and add up to negative 5 minus 3 minus 2 work, right? Is equal to 0. So basically, when does m minus 3 equal 0? When does m minus 2 equal 0? Add an m value of 3, add an m value of 2. But remember, we're not solving for m, right? We're solving for x, so we just brought that m in temporarily to make things look a little bit nicer and easier to deal with algebraically, but now we have to bring back that 2 to the power of x here. So we have to solve, when does 2 to the power of x equal 3? When does 2 to the power of x equal 2? Well, let's start off with this one here first. This one is easy, right? 2 to the power of x equals 2 to the power of 1. Same base, we could just drop them, right? So x is equal to 1, so that is one solution. Over here, I can't write the 3 as a base of 2, so what we're going to have to do, we're going to have to do it the brute force way, where we log both sides, then we could bring that exponent down, right? So it'd be x log 2 equals log 3. So that means x is going to be log 3 over log 2, right? That's the exact value right there. You may also see this, instead of them using logs, they'll use ln, right? Log 3 over log 2, that's the same as ln 3 over ln 2, right? If you plug both of those in your calculator, you would notice that it's the same decimal. And the decimal value is 1.585. Right, so that is the other solution right there. So whether you have it as exact values or decimal, that is the answer. And then you could check these, right? You could take these, plug them back into the original equation, and then see, does the left side equal the right side? The right side is only 5, so you'd have to basically plug both of these in here for the x's and see, do both give you that left side equaling 5, and they should. This one we rounded a bit, right? So it should be something very close to 5. The one would give you 5 on the dot. Another thing I want to mention before we get to the next one is that there is another way that some profs, some teachers show to do this kind of question. So it's not my preferred method, but thought I would show it in case that they do, just to not alienate anyone, and to show you that we actually end up getting to the same result here, is that they'll notice that this 2 to the negative x, well, they'll multiply basically the entire left side by 2 to the power of x, right? They'll multiply it by the positive exponent of whatever that negative exponent is with the same base. What you do to one side, though, you got to do to the next side, right? And so when they do that, what happens is this 2 to the power of x is going to have to get distributed to the bracket. So this would be like 2 to the power of x plus x. You would add those. That'd be like 2 to the power of 2x plus 6. And then notice you're going to have 2 to the power negative x plus x. And those are going to net out to 0. Right? Those are going to net out to 0. So here you'd have 2 to the power 0, which is just going to be 1. So you're going to be left with 6 here. This is going to be 5 to the power 2x. And then over here, you can rewrite this as 2 to the power of x squared. And then if I bring back that variable, right, where we let m equal 2 to the power of x, watch what happens. M squared plus 6 equals 5m. All right, plugging in m here, plugging in m there, notice we end up with the exact same quadratic equation right there. All right, and then the other steps are the same. So that's another way to do it. Personally, not my favorite. I feel like just there's a lot more going on there versus just bringing the 2 to the negative x down and then bringing in that m and then dealing with an equation from the get-go. In terms of m, I feel like it's easier to work it like that, but just in case maybe your prof or your teacher shows it this way, didn't want to alienate anyone, and then you could see we end up with the same result there. Then moving on to part B, so let's continue it here. So we're going to have e to the x, same thing now, we got e to the negative x, so I'm going to just bring it down, make it a positive, and that's going to equal 5, right? Because there's like a 1 in front there, imaginary 1, so that's where that 1 is coming from, versus over here there's that 6. That's why the 6 was in the numerator. Over here there's a 1. So now we have all positive exponents, same thing. I'm going to bring in that new variable. M in this case is going to be e to the x, so we're going to have m plus 1 over m is equal to 5, like that. And then, yeah, multiply, this is m over 1, 5 over 1, multiply everything by the lowest common denominator, which is m in this case. So m times m is m squared. These m's cancel out, that's going to be 1. This is going to be 5m, like that. And so we'd have m squared minus 5m plus 1 is equal to 0, right? And then in this case, this is actually not going to factor smoothly, right? So in this case, we're actually going to have to solve for the m value with the quadratic formula. So it'd be negative b, so it's like negative 5 plus or minus b squared, negative 5 squared minus 4 times 1, right? The a value is like 1 times the c value of 1 all over 2 times 1, like that. So what's this going to simplify to? 5 plus or minus, this is going to be 25 minus 4, so root 21 all over 2. And then when you put it through the quadratic formula here, right, the two solutions, because of the plus or minus, you're going to get an m value of 4.7913 and then an m value of 0.2087. But remember, we're not solving for the m value, right? We're solving for x. M was just temporarily here for e to the x. So what you have to do is basically bring back that e to the x and sub it in for the m values, like that, and then you have e to the x equals 0.2087, like that. And just in general, if you ever have e to the x equaling m, you want to get the x by itself, you just ln both sides, right? And then ln of e is just 1. So basically x is equal to ln m, right? This is a rule, standard rule over here. So exact same thing. Basically, x is going to be ln of 4.7913. And then over here, x is going to be ln of 0.2087, like that. And so if you plug that in your calculator, you would actually get plus or minus answers. So x equals positive 1.567, or x is negative 1.567. Right, and those would be the two solutions for this equation here. And again, you could test these, right? You could take this, plug it in. The right side is just 5, so if you plug this in to the left side here, should equal 5 or something very close to 5, right? We did round it to 3 decimal places. And if you plug in negative 1.567 here as well, should get something very close to 5. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.